Hello friends, this video on aldehyde ketones and carboxylic acid part 6 is brought to you by examfear.com. No more fear from exam. Let's understand the structure of carbonyl group because the whole chapter is about carbonyl group, its properties, chemical properties. It's good to understand the structure of the carbonyl group. This is the typical structure of the carbonyl group. This is my carbon here and I have two alkyl or aryl group attached or hydrogen also. And this is oxygen here, and oxygen is more electronegative than carbon, so oxygen will try to attract electron towards itself. So electron will slightly move towards oxygen, and so oxygen will develop slightly negative charge and carbon will develop slightly positive charge. And the angle between them is 120 degrees. That is the structure. Let's understand the structure in little detail. This is my carbon. This is my carbon. The carbon electronic configuration we know is 1s2, 2s2, 2p2. Carbon is 1s2, 2s2, 2p2. Since this is not taking part in the reaction, we'll ignore this. We'll consider this 2s2, 2p2. This is how it looks. We've discussed this in the earlier chapters. And if you don't understand this, watch my previous videos where we discussed the electronic configurations of a particular atom. So now what happens is due to hybridization, this one electron moves and everything is half filled. This is more stable, so it goes for sp2 hybridization. So now if you see, the same carbon went for sp2 hybridization. This is the structure. If you see here, right, there are 4 electrons in the green. This is my sp2, sp2 and 2p. This is my 2p and the other ones are my sp2. Correct? This is my 2p, the one horizontal, and this is my sp2. This is how the carbon atom looks like. And there are 2 alkyl groups that are attached to it. If you see, this is my carbon, this is my carbon, and there are 2 alkyl groups attached to it. Alkyl or aryl, whatever it is, that is attached to it. Now I have oxygen here. So let's see the oxygen also. This is my oxygen. Right? For oxygen, the electronic configuration is 1s2, 2s2, 2p4. This is how it looks. Right? This is oxygen. Since 1s2 is not taking part in the reaction, these guys take part, the 2s and 2p. I just showed you 2s and 2p. And this is my oxygen. Now if you see, this is how it becomes. This is also sp2 hybridized, these two. And I have my 2p orbitals. 2 empty 2p orbitals. This is a mistake. This is also sp2. Yeah, this is also sp2. So 3 sp2 and 1 2p. So this is my 2p, the horizontal one. So here also I have 1 2p. Here also I have 1 2p. Correct? This is 2p. Now what happens is, this forms a bond. So if you see, this was my 2p. Right? So now if you see, this is one sigma bond. And this is one pi bond. So this is also overlap. This will overlap. And thus if there is a double bond. 1 sigma, 1 pi. So this was my sigma bond. And this is my pi bond. And that is how, if you see, it looks like. This is my carbon. And there 1 pi bond. Right? So 1 pi bond, if you see, is like a sandwich. It's 1 sigma bond. And this is my oxygen. Actually, if you see, this is my carbon. And this is my oxygen. Right? So this is a sigma bond and this is a pi bond. So this is the typical structure of a carbonyl group. And this angle is 120 degree. This angle, right, is 120 degree. This angle is 120 degree. So if you see, this was sp2 hybridized, this was sp2. And this is my carbonyl group. Hope you understood the structure of the carbonyl group. And these are my lone pairs. If you see, oxygen, these are lone pairs. This is my lone pair, 2 lone pair. It's all there. So it's all in a plane actually. It's all in a plane. So if you see, this is kind of structure it is. It's all in a plane. This is my carbonyl group. This is oxygen here. and this is my 2R, and they are in a plane. They are all in a plane. If you see, they are all in a plane. Want to draw, this is all in a plane. Correct? And this is double bond. This is all in a plane. And they have two lone pair of electrons. And these, you can have any R or R here. And this angle is 120 degree. So this is the structure of carbonyl group. It's all in single plane. Let's draw some structure. Let's take some numerical. We'll draw the structure of 3-methyl butanol. I'm drawing this in blue. 3-methyl butanol. So let's first draw a butanol. Meth, eth, pro, but. It is butanol. That means at one position I have aldehyde. Right. So let me number this now. Starting from aldehyde 1, 2, 3, 4. At 3 I have methyl, so I add a methyl here. This will be the structure. If you want, you can add hydrogens. Here are 3 bonds, only 1 hydrogen. 2 bonds, 2 hydrogen. This is the structure. Let's try with the next one. Para-nitro propiophenone. So let me have first phenone. This is my benzyl. At para I have a 9. This is the propiophenone. So meth, eth, prop. This is the propiophenone. And para I have a nitro. This is my para position. Let me add nitro group here. So this is my structure. I can add hydrogens. This is C. Para nitro you can ignore now. Propiophenone. This is my propiophenone. And then at para position let me add a nitro. The next is what? Para-methyl benzaldehydes. Let me draw benzaldehyde first. This is my benzaldehyde. And para position I have a methyl. This is my para position. Add a CS3. This is my para-methyl benzaldehyde. Similarly, 4-methyl pent 3-ene 2-one. So it's pent, right? Let's me first draw 5 carbon. 1, 2, 3, 4, 5. Pent is done. Let me number it. 1, 2, 3, 4, 5. Anyway, again number. Now at 3 I have ene. So at 3 let me put a ene. This is done. At 2 I have a one. At 2 let me put a one. This is done. At 4 I have methyl. So at 4 let me put a methyl. You can add remaining carbon. So remaining hydrogen. This is the structure. Correct. Let's try one more. 4-chloropentane 2-one. It's pentane. So let me draw 5 first. 1, 2, 3, 4, 5 is the pent. Let me put the number. All single bond. Okay. At 2 I have a one. Let me put a one at 2. This is done. At 4 I have a chloro. Put a chloro at this. This is my structure. Other things you can just put extra hydrogen. And the CH3. Correct. The next is 3-bromo-4-phenyl pentanoic acids. Let me draw first pentane. 1, 2, 3, 4, 5. Pentane is done. All single bond. Pentane is done. Pentanoic acid. That means this is my COOH. We'll discuss about this when we discuss carboxylic acid. This is pentanoic acid. This is done. 3-bromo. Let me number it. 1, 2, 3, 4, 5. Numbering starts from this position. So at 3 I have a bromo group. And 4 I have a phenyl group. This is the structure. The extra hydrogen you can add. Similarly, P-dihydroxy benzophenone. dihydroxy, you can ignore first now, you just focus on this benzophenone. So let's draw benzophenone first. So benzophenone we know is nothing but this. Now at P and P dash, this is my P position, this is my P dash position, right? I have hydroxy, 2-hydroxy group. So let me add 2-hydroxy group. This is my thing because this is my P and this is my P dash position. The next is hex 2-ene 4-ionic acid. So let's draw hex first. 1, 2, 3, 4, 5, 6 is hex. This is done. Let me number it. 1, 2, 3, 4, 5, 6. At 2 I have ene, so 2 let me draw ene. And 4 I have to draw ionic acid. And 1 I have to draw obviously acid. And 4 I have to draw ionic acid. 1, 2, 4 ion actually. So 4 is ion. Yeah. 2-ene, 4 ion. And ionic acid. This is the structure. Hex, 2-ene, 4 ion, and then acid. So at 1 I have to draw COH. We have to draw a structure of alpha methoxy propionaldehyde. So this is my propionaldehydes. Let me draw propane first. And alpha aldehydes. Let me draw aldehyde. This is done. Propionaldehyde, it's all single bond. Alpha, this is my alpha carbon. Alpha methoxy. Alpha I have OCH3. This is my structure. You can put remaining hydrogen. There is 1 hydrogen here. The next is 3-hydroxy butanol. Let's draw but first. 1, 2, 3, 4 is but. Let me number it. 1, 2, 3, 4. Right? At 3 I have a hydroxy group. Put a OH. It's butanol. That means at 1 I have COH. This is the structure. Other hydrogen you can just add. The next is 2-hydroxy cyclopentane carbonaldehyde. So let me first draw cyclopentane. And let me number it. 1, 2, 3, 4, 5. At 2 I have hydroxy. Okay, done. 2 hydroxy is done. Cyclopentane is done. Carbonaldehyde. So carbonaldehyde, that means at 1 I should have carbonaldehyde. This is my structure. Here again I'll ask you guys to pause this video for some time and try to draw the structure on your own, and then you can just validate if you have done correctly. So 4-oxopentanol. Let me first draw pentanol. Pentanol is 5. 1, 2, 3, 4, 5. And pentanol. So this is aldehyde. And I can number from here. 1, 2, 3, 4, 5. Correct. At 4 I have oxo. At 4 I have a oxo. Hydrogen you can add. Disec-butyl ketone. That means this is a common name, is a ketone, and 2 side have sec-butyl. Sec-butyl is something like this. So this is my structure. It's my ketone, disec-butyl. Then I have 4-fluoroacetophenone. So my acetophenone is this. And 4-fluoro, this is 1, 2, 3, 4. This is my fluoro. So 4-fluoroacetophenone will look like this. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.